Um, okay, let's get this one here. So if you guys grab your book and have it handy in front of you, and let's just walk you guys through this book. The most important thing in this book, I always say, guys, read this book once in your lifetime. There is a lot of information. I don't read it every time I teach this class. I pick certain things, the most important things. But there's a lot of information. Very, very nice book. I think it's a very nice book, guys. Introduction to commercial project. So if you guys go to chapter 1, please, and have the chapter open in front of you, and let's just walk real quick through a couple of specifications and blueprints and electrical things. Okay, so commercial building plans and specification. I want to remind you, Andrew, that we have two projects this quarter. One project you guys are doing in Revit. The other project is the book is following it. Okay, so I had the students get confused. Which project are we talking about? The book that you have, the commercial book, is following a multi tenant commercial building, not just one tenant, multi-tenant commercial building, and they're designing a complete electrical and low voltage and lighting system for this building in this book. So what we need to do, Aaron, is kind of read the book and try to pick up the best ideas and reflect them into our project. Not like we lack ideas in our project, we have tons of ideas, but it's really nice to see when you design the system and read the book, see how those guys design their own commercial building. The nice thing about this book that I like is our building is one tenant, it's owned by one people. So this project, it introduces you guys to a strip mall. You walk into a strip mall and there's all these little shops owned by different people and operated and run. And you have to design a distribution system for them. So you get into metering multi-meters. In our commercial project, we have only 1 meter because it's only one owner. In this project, in the project that you guys are doing for me, this project has, I think, what is it, 6 people are in this building with 6 different meters that's going to be with them. So it's really cool concept. Okay, a couple of things that we're going to do, guys, about this. I hope by the time you leave, guys, the NEC code book becomes a big deal for us. So we'll talk about the articles and the sections and the exceptions for the NEC code book. This is typical for all the things that we're going to be doing there. NEC code book. Updating the NEC code process, since it's the Bible, it's really nice to know how they update these ones. So we'll say a few things about updating the NEC code book and reports on comments and reports on proposal and so forth. So that's what one thing I'm gonna, oops, disregard that one. Okay, my technology is okay. I'm gonna move this one away from me here. Okay, so it doesn't distract me. Okay, we talked about the updating, understand safety rules. I know you guys are not electricians. We talked about this one, but you will be around electricians. Most of you are not electricians. You will be around electrical people who are opening very dangerous pieces of equipment that they could explode and kill you. So we'll talk very few things about working around electrical equipment. And contract documents, specification. I'll talk more about this one, guys, the specification contract, when we go into the last class they're going to do with me, which is estimating and project management. Application of building plan specification. Every building you're going to do design, it's going to have 2 parts, one specification, one plan. You guys remember that big set of things that you printed for me? And I don't know, some of you looked at it, some of you don't. That's a specification. That's your legal documentation of the project. So we're going to get deeper into that one. Locate specific information on the building plans. When you read, I know, Jeff, you were answering some questions. Really nice to be able to read the blueprints, the non-electrical blueprints. We don't focus too much on reading non-electrical blueprints, the plumbing and the architectural, but that chapter helped you do that one. Obtain information about industry-related organization, UL, and so forth, and SI system. We keep talking about the international unit system, the international system of units. We'll talk of every chapter that we cover here is going to always, guys, talk about the international systems. And I always tell the example, you think we use the standard a lot in the US, but you'll be here downtown Minneapolis working for projects somewhere else in the world that are using the SI system. So we don't emphasize it a lot here when we do the calculation. We always do volt ampere square foot. but right next to it, between parentheses, is or right next to it, you're going to find also volt ampere squared meter. So you can do the calculation based on the squared meter. Okay. So introduction to NEC code book, safety. The whole idea of the NEC code book is the safety of the people and the personnel as well as the equipment, and the safeguard of the equipment that for the building that we use. Wiring methods, all the wiring methods, all the luminaires, everything is listed in the NEC code book. Why can't I use Jeff barbed wire as one way of wiring methods? Because barbed wire is not listed in chapter 3, right? Why can't you use a coffee can as a fixture holder, right? Like people will be creative because it's not listed by UL, and it's not listed by UL, then I can't, and the code says if it's not listed by a third party, then you can't use it. That's what prevents people from being so creative and allow the inspectors to stop all this nonsense. Well, not nonsense. I hate to be against creativity, but the dangerous creativity.
People actually did that. They have someone who was actually done it for all the people pulled out of their houses.
I saw that. That's why I say coffee can. Yeah, they make a coffee can as a light. Is that the same thing? Yeah, that's why I mentioned the coffee can. So people are so creative. Okay, we're going to be using the text NEC code book. Okay, so I'm going to go over that one. Every time we talk about electricity, guys, we talk about dangerous. I want to highlight the word dangerous. I want to highlight the word OSHA, and I'm going to highlight the word 70E. These are related, and some of you guys wonder, Jamie, why I'm a designer. I'm not going to be in the field working on electrical equipment. I can't emphasize. You guys will be around electricians working in the electrical field. In the electrical field, when they work in the electrical field, I always give this example. I was on a project with Bloom Engineers working. We went downtown Minneapolis, so the Hennepin County Government Center, no, Hennepin County Court. And we walked right into the court, and we were looking at the distribution system. And the electrician came and opened a big switch gear for me right there. I'm the engineer. So he dressed up, opened it, and I'm supposed to get in there, take my pictures. Now, would it be an arc flash? Could an arc flash happen while I'm taking my pictures and taking my measurement? Yes. So you are around electrical equipment. Yes, you will not. When you work as a designer, Jeff, you are not licensed, bonded, or insured to open or work on energized or non-energized electrical system. We don't carry tools unless you are hired as an electrician. I was a master electrician at that time, but I wasn't hired by Bloom Engineers as a master electrician. I'm an engineer. So we're not bonded or insured to do electrical work. We're bonded and insured to do design part. So be very careful with that one. So dangerous. There are two dangers, guys. Everybody knows the two dangers that we have. One danger comes from the arc flash, big ball of fire, blow up in your face and burn your face. And the other one is the touch, the electrocution, touching anything electrical. Two hazards from electricity. Hazard number one, electrocution. You touch something energized and you die. You burn, right? The other one, the dangerous hazard is explosion, arc flash. You're working in electrical equipment, boom, an arc happen inside this equipment and burn you and kill you. These two are the dangers that are going to be encountered. You guys, mostly the arc flash is a big deal. So when you work in electrical equipment, Zach as a designer, the rule of thumb OSHA and 70E and good practices require you, if this is a panel, and Jeff is an electrician hired to work on this one, move 10 feet away. And that will be that's the safest boundary of arc flash. So typically the arc flash guys within a couple of feet away from it. The safest point is move at least 10 feet away from the place where people are working. 10 feet away. If you don't do the calculation, your arc flash boundary, they call it arc flash boundary, is 5 feet. Meaning that big ball of fire, how far that big ball of fire from the panel is going to go? Typically 5 feet unless you do the calculation. So if you put yourself 10 feet, you are completely out of the arc. That big ball of fire is going to chase you. Okay, so 70 and OSHA guys do talk a lot about and qualified person. I'm going to highlight these ones. So between here's dangerous, qualified person, and OSHA and 70E work for a qualified. If you're a qualified person, you have knowledge and the skills of operation and construction of electrical equipment, then you have to follow the rules of OSHA and 70E, right? And if you follow the rules of OSHA and 70E and work on energized equipment, your chances of surviving is much higher. Cool. Any question, guys, about this? Remember the word qualified person. If you're not qualified, you can work on energized equipment. OSHA enforces, this is the law, the safety law, right? We all know the safety law, um, Safety and Health Act, and all this good stuff. And then 70E is the electrical part of OSHA, the electrical part of OSHA. Any question, guys, about this? Any question about this safety? So I can't emphasize, you guys are a designer, you also have to know this one. Now, you're a project manager, Kerry, and you're working on a construction site. You know that all the receptacles on a construction site have to be GFCI, 15, 20, and 30 amps, all GFCI or GFCI protected. So when you're using portable electrical power straps on the job, what do you think they have to have? GFCI protection. So that's what, you are not going to be installing it, but you're a project manager. If you see your people who work on your project, they don't have GFCI plugged into GFCI, what do you need to do? Remind them. It's your responsibility. Arc flash, arc blast. This is the most dangerous, as I said, guys. Arc flash, arc blast. We go through, for more info, if anybody wants more, I have 4 hours of OSHA, of 70E training on YouTube. If anybody want to go there, you get detailed stuff about the arc flash. Long story short, you open this panel, Jeff, you drop a screwdriver right in, big ball of fire comes at you, and that big ball of fire, typically, unless you do the calculation for it, it's 5 feet. So you have the boundary of that ball of fire is 5 feet. If you are within 5 feet distance, your chances of having first, second, or third degree burn is very high. Number one. Number two, if your chance of being pushed against the other wall as a projectile is also very high, and your chances of losing your hearing because it's so loud is very high. The chances of using your vision is also very high. So there's a lot of issues involved in it. You can, copper will expand, guys. This temperature will expand the copper and aluminum and make them bullets. When you have an arc flash condition inside the switchgear, it could create basically multiple bullets shooting at you. So there's a lot of issues involved in arc flash, arc flash. So what's the rule? Since you're not electricians, your rule is 10 feet away. If any piece of equipment is being worked on, energized, Zach, in the field, you have to move 10 feet away from that piece of equipment. Can I have thumbs up, Chad? We got that one? To save yourself. You guys are not going to be working on that. And also, small faults can cause a lot of arc flash. Enough if you guys don't work on it, but if you're working on it and you're sitting right there, an arc right in front of your face, and you don't have the proper shield, you could lose your vision. You could lose your vision. Any comments? Can I get you to be scared of arc flash, arc blast? If I get you there to be at least scared of that one, I did my job. Here's that stuff that you need to do. Portable GFCI protected plugs that you need to do. All the panels, including this panel, I hope so, have to have caution, OSHA, front and front panel. There is no arc flash label here. Oops, no, here. Arc flash label. Appropriate PPE required. By code, by law, NEC code book and OSHA requires a label like this. So when the electrician or you, as an apprentice, standing in front of a panel and the electrician open for you, you have to be warned that there is a big ball of fire could come out of the switch gear if you drop a screwdriver inside the switch gear. You know, most of us are smart enough not to grab on energized objects, right? Most of us. But some of us, when you're tired, guys, and you're working, could you drop a screwdriver right into the panel when you're tired at the end of the day? You could have, right? A hinge falls off and land a face to ground. That's a ground fault. Could that happen? It could happen. A bolt that you're holding in your hand drops. Anything could happen. So when you push it hard, it fails and arcs. So a lot of things could happen inside the panel. So you need to have this danger, arc flash, and shock hazard. So you required personal protective equipment, gear to protect you. I don't talk too much with you guys about the PPE because you are not required to work on energized. For Andrew, my friend, if you need more information, I encourage you to look at my 4 hours of 70E training. It goes through the different categories, category 0 through category 4 of the protection. And here's what Andy Secret book require you. Now, whom am I going to? Adam, you, my friend, at your firm, when you work for an engineering firm, you're going to make money out of doing the calculation here. They're going to hire you, which you guys are going to do with me. You're going to be doing load calculation to come up with this label. So you're going to be doing load calculation to come up with this label. So that's a good, a good source of income for you guys in the engineering firm, and also a good safety. You're going to be analyzing the power system and coming with this label. Can I have thumbs up, Chad? We understand. This is, if I know how to do that, first, I will save lives, and second, it's also, of course, it's going to be a source of income for your engineering firm. This talks about standing to one side of the panel. If you guys are working on this panel, you're going to open it. If you stand right in front of it and there's an arc, what's going to happen to this arc? If there's an arc in front of you and you're standing right in front of the panel, what's going to happen to this arc? It's going to hit you right in the face, right? So stand to the side. You guys don't work on these. So you need to have the PPE, the protective, the PPE, the right protective, and we talked about this one details with electricians, and safety signs. You have to have signs around the equipment and so forth that comes from ANSI. So this becomes a big deal, guys, if you're a project manager, how to isolate the area that you're working on, energize, or somebody is working on in your project. So that's all we're going to talk about in terms of safety. The only thing I want to emphasize, if you guys want being designers, if I can get you to understand two things. As a designer, you're not allowed to work on energized equipment or non-energized electrical work. You're not licensed, bonded, or insured, right? But you will be in a situation where the electrician will be working on equipment and you are around them, or you have to stick your head to take some pictures to modify switch gears. Be aware of the hazard. Number one, don't touch anything. Assume everything is energized, right? And number two, assume that there will be a ball of fire coming out of this piece of equipment if you drop something or somebody else drops something inside the switch gear. So Zach, what do? Get in, take your pictures, get out as fast as you can. Okay? And if you are a project manager, Aaron, my friend, in a job, be aware of all these, because the responsibilities of the people who work for you, part of their responsibility is yours to adhere to all these rules. So I'll go more over these guys when we go into project management and estimation. Okay, a specification. This chapter talk about specification, guys. And there's multiple sections of specification. Specification that comes with it, the clause and the condition. Section number one, almost always section number one have legal requirements of the project. That will be the one that you're going to sign and document, and becomes that legal document for you. So this will have, typically it has notice to the bidders, the schedule of the drawings, proposal, agreement, general conditions. So this is where you're going to tell them, I'm going to be doing this amount of work for this amount of money, and for this amount of time, right? And I will not be doing this amount of work based on the agreement. So it's everything that you're supposed to do, you're not supposed to do, the time and the dollars. So that becomes, when you sign it, what does the proposal, when you sign the proposal, becomes your binding legal document, right? So that's a specification. Supplementary general conditions, we have other general conditions related to the second section will be the general conditions, and you guys can read through all these. I gave you a bunch of them last semester and last project. So contractor must instruct all crews. There's a bunch of things that you can do under the contractor must verify the existing conditions and measurements. Contractor must employ qualified people, and so forth. So there's a few things that you can read about what the contractors can do. Then contractor specification. This section's contractor specification, or this will be for us 1600, Spec 1600 or 26,000. These are specification that we have, electrical specification. So you guys, the one that you printed for the project, remember that set that you printed, that will be under contractor specification, electrical, mechanical, architectural, and so forth. So there will be specific, discipline specific specification. And we will talk again, we'll talk a lot about these one, guys, when we talk about the project management and the estimation. So for the time being, you guys are familiar, I know you're familiar with the 26,000, the series 26 that I gave to you. That's the series that comes 26,000. It used to be 16,000, and then every spec has its own name after that. Okay, so that's the blueprints. The blueprints are the drawings. So construction plans for the drawing. You guys are doing it right now. Why do we need all this document? This becomes part of your project, right? Legal binding project. And also you have to submit it to the local government agencies for approval. You build a hospital, you're going to submit this hospital to the city council for approval, right? That's going to be, so approval, blueprints and specification, especially blueprints, will be used for getting approval from the cities, as well as from utilities. You want to go power, they ask you to have a riser. Give me the riser or the major equipment that you're going to have, the electrical utilities, so they can see if they have enough juice to feed you. Okay, and there's a directory for all these construction terms and specification. We go more over this one, guys, more when we do the project management. Cities and power companies. When you guys do the specification, especially certain cities will have their own specification for lights, ordinance that you have to do, especially lighting. As you're going to see, like City of Bloomington, tough to do lighting outside. You have to take a lot of, they maintain certain amount of lumens that you can keep because of light pollution. They don't want you to shine a lot of light into your neighbor's bedroom, right? Especially for commercial tenant, because people want to sleep at night. They don't want a big floodlight shining right through your bedroom window. So there's a lot of ordinance that come from the cities. Power companies excel, have a lot of regulations. You need to tie, you need to do certain things. So these will you get involved in a lot of rules and regulations related to the code from these companies. All these guys typically, at least in Minnesota, will be based on the latest NEC code book done by the NFPA. And you guys by now, I hope you know this is where the NFPA is, right? The NEC code book. And what's their job? These guys, their job is to protect buildings from fire, buildings and properties and people from fire, right? Initiated from fire. So part of it, NEC code book is, the funny thing is, National Fire Protection Association, why would a firefighters write a code book, electrical code book, right? Fire can be initiated from many sources. The NEC code book is focused on which source? Electricity. So remember, if you go to the documents, the NFPA has tons of other documents, fire related to the fire that has nothing to do with electricity. So we only focus on NEC, which is what? Only electrical initiated and activated fire. So just be aware of that one. I hate, the Bible or whatever your belief system is. I use this word all the time. National Active Code, if you guys do not know the NEC code book, you can't design system. Unlike the Old Testament and the New Testament, these are updated every 3 years. It would be nice if they update the Old and the New Testament and the Quran and all the stuff every 3 years. Oops, did I say that? They will. There's every 3 years you have to update them. Unlike the other documents that you have to live with forever. Must be constructed before, so must be consulted before you design or make any decisions. Yesterday, guys, not yesterday. Yesterday you weren't here. On Friday, we did load calculation. I told you when we reach a panel, we can go up or we can go down, right? But we did everything based on the NEC code book, right? We were saying we were pulling information from the NEC code book. Why? It's the Bible. If there's any conflict, you're going to go to court. They're going to refer to what? What's the industry standard? Electrical NEC code book. I can't emphasize more. How is it written? By proposals of people like yourself, very smart people. You think you really don't like the way they do calculations, Zach? No problem. Write a proposal, send it to them, and then they say, Zach, who the heck is that guy? Haven't heard of his name. Oops, throw it in the garbage. No, they don't do that. They study the proposal, they give it to a technical committee, and they read your proposal and compare it and contrast it with other things, other proposals and other things, and if it makes sense, they adopt it, and it becomes part of the law. And most of the people who submit proposal, guess what? They're electrical engineers and electricians and contractors who are working in the field. So it makes a lot of sense, but it might make sense in Texas, but not in Minnesota. So that's why all these committees have to look at applicability and so forth. Okay. Proposal. So when you guys send your proposals, they write this So code making panels. There are how many code making panels? 14 or 15 or 16, I can't remember. The code making panels at the end of the book, those are the guys who decide, the beginning of your NDC code book, we have 19 code making panels, 19 code making panels, 19 of them. If you can see CMP right at the beginning of the NDC code book, guys, those are specialized in every multiple sections in the NDC code book. They take them and they focus on them. So code making panels. So they get your proposals and they submit report on proposal. After they get your proposal, in the report they say accepted, rejected, or future discussion. After that one, then they send the report on proposals. They make it published for you and I and everybody else to comment on it. After we comment, they submit another report called reports on comment. Report on comments. After they filter, see how many, first they filter through it, they put in a report, filter it again, report on comments. So you comments, say, are you crazy? You guys are adopting things that's going to screw up in Texas or anywhere else. After that, it goes all the way to the adoption stage, after the report. Right now, guys, in 2014, in NEC 2014, we are at report on proposals. There is report on proposal. I downloaded report on proposals as of now. Soon to be, there will be report on comments. So I can tell you what they're proposing for 2014 NEC code book right now. I have a copy of it. Cool. Any question, guys, about this? And then it's published by NFPA. After they do these reports, they put it for the public to comment on it. Then it's published. Okay, the single most important thing, guys, about NEC code book, please understand this fully. The code arrangement, chapter 1 through chapter 4, this is where you're going to spend probably, I would say, 90% of your time. 90% of a lot of people's time is going to be spent from 1 through 4. You have the general, you have wiring protection, wiring methods. Every single wiring method got created in chapter 1. And equipment for general use, transformers, generators, and a bunch of it. These are, we're going to spend how much of your time? Close to 90% of your time. These guys are specialty where you can spend probably 10% of your time on it. It goes for special equipment, special occupancies, hazardous location, special equipment, as well as special condition. And then you get into, if you're doing telecommunication, can you guys see that? That's where you're going to have a whole chapter for yourself. And all the calculations in the tables are in chapter 9. Everybody can see that? And so rules in chapter 1 through 7 applies only if it's referenced for this chapter. It's almost not part of the whole book. And then tables are applicable as referenced only, and annexes are FYI only. Annexes are FYI only. Everybody knows what an FYI only in terms of enforcement? Can't emphasize this sheet. Can I have thumbs up, Chad? We fully understand how the code is laid out. And these are my numbers related. So if it tells you how many conductors CHHN you can fit in a conduit, and if you go to in a conduit rigid number 14 in a rigid conduit 3/4 of an inch. First, you're going to go to chapter 3 to the article that talks about rigid. There they refer you to tables in chapter 9 and annexes. Annexes that it'll tell you to calculate it, go to annex this to find how many conductors. Then it becomes reference. Any question, guys, about the arrangement of the NEC code book? As we move forward, we have been pulling information from everywhere here as we go. Contains 19, what's covered, what's not covered, and the style, guys, you're going to see in a second here. Exception and citing references. When you design anything, remember, we are designers. When we design anything, if it's not referenced in NEC code book, it's opinion, right? It's an opinion. If it's referenced, then it becomes as close to a fact as you can get in this business. There's a lot of exceptions to a couple of things. Article 100, guys, I always say, Adam, if you want to understand the NEC code book, when we teach the apprenticeship, there's close to all, if you ask me, all the definitions, you have to read all the definitions to understand the NEC code book. But at least there's 100 definitions that apprentices have to know. before you even start to understand any secret book. Number one, approved, accepted, approved by the inspector, accepted by the authority having jurisdiction. Authority having a jurisdiction, legal jurisdiction. So you have to have an elected entity to select you to do the authority having jurisdiction. Identified, have some type of identification, labeled and listed. This is for equipment. Your equipment have to be labeled and listed before you install them. You have a NEMA right here on the wall, right? This have to be, you have to have a UL listing and labeling on it, otherwise you cannot install it, inside, outside. So, right, equipment have to be labeled, have a label on it, listed on a list. Otherwise, people will use a coffee can as a lamp holder, right? Because it's be very creative, cheaper. Rules, a lot of things, guys, in any secret book, as you probably know by now, with shall not, these are the rules. Shall, you have to do it. Shall not, you can't do it. Or shall be permitted, it's up to you. And this is fine print notes, they change it to information note in 2011. Information note is FYI only. If you see it for, you can do it, it's FYI only. All the equipment that you have to do have to be identified for the use. For example, I have to put a lighting fixture outdoor. Do you think it has to be identified for what location, or no? It's not a big deal. Putting a fixture outdoor, not identified for what location, right? It has to be identified for what location, because it's outdoor. If it's indoor, does it have to be identified for what location? No. Can I put this fixture above your head and go put it in a parking lot right now? No. Why? It's not listed and identified as used. For this is listed, right? This piece of equipment here listed. UL listed piece of equipment, right? But can I put it outdoor? No. Why? It's not identified for the use. Just because it's listed, it has to be used according to the listing and labeling, right? Wet location, dry location, dry location. These are directly from the code. Yep. And if you go to Article 100, they are defined in Article 100.
But you were saying listed as a UL.
UL, or they call it third-party verification. UL, notoriously famous UL. But there's other parties, accepted parties that can list equipment too. But I would say if you are in the US, if you're UL listed, you're 99% of the time you're UL listed, or 90% of the time. Okay, speaking of UL, here's UL listing. UL listing, the way UL listing is, and I told you guys about this one in the past. Okay, Brian, my friend, you have a 4,000 amp switch gear. You said, I made a 4,000 amp switch gear, right? Well, and then Jamie wants to buy it. Jamie has no equipment to test that this switch gear can handle 4,000. You don't have the equipment, right? So he's not going to trust your word. Now, would you trust the word of the people who are going to sell you the equipment? Of course not. You need a third-party verification. That's where UL comes. And they have labs, and they're specialized there, my friend, in taking these equipments, burning them. You said, this is a 4,000 amp switch gear. You handle 4,000 continuously. Yep, let's put 4,000 in that sucker, and let's see what's going to happen for 3 hours. If it stands, get you a list on it. If it doesn't stand, it fails, send it back to the manufacturer. You can't put you a list on it. Does that make sense? It's a third-party verification. Very smart, competent group of people sit in a big area with a lot of equipments and test these equipments, and based on what the manufacturer is telling us that they can do. You say this light is going to create 2% harmonics, right? Can you measure that's 2 harmonics? 99% of the people have no idea how to measure that, right? Take it to UL, yep, go power that things, put meters on it, measure, yep, it's 2% or less. Check, UL. Does that make sense? Without them, it's hard to install equipment. Okay, so you have to have a list. So then they give them a label, UL label, and they put them in a list that you can basically request to verify that what you're buying is what you're getting. What you're paying for is what you're getting. Counterfeit is a big deal, guys. We talk a lot about manufacturers. I can give you a good example. I work for C Electric, and we had a clinic here in Minneapolis. Let's tell you this example, and when you do healthcare facilities, clinics is one of them, you have to use two grounds, right? So now you go buy, it says healthcare facilities on the cable, but it was made in Canada, and it doesn't meet the UL listing here. So our electrician bought it because they're all over. I mean, it's open market. Install it, the inspector refused to approve it. You know, even though it has two grounds, but it's not listed to be used in the U.S. in the healthcare facility. So it's not counterfeit, but it's not listed. So it creates a lot of issues. The term that they use for them was nationally recognized testing laboratory. Those are a group of very competent people that they basically Kerry is going to sell me a cow. They go to that cow and they make sure that the cow is worth what it says it's worth and does what it does. A switchgear, the switchgear is going to do what it's supposed to do, right? Verify it by testing, not just read all through a specification and test it with a very competent group of people. So it's really cool. If you ever talk to somebody from UL, their job is to blow up things. Make sure they test them to the limit. Make sure they're going to handle it. And in the electrical industry, UL is not just, UL does a lot of other stuff, guys. So, and then if there's any legal issues, a UL equipment list, guys, at least get you a chance of winning a case. If you burn a switch gear, it doesn't have a UL label on it or any third-party verification, do you think you're going to win the case? You're not going to win a case from a get-go, even if you follow the NDC code book, A bunch of these, here's another one, guys. ITS, safety testing electric equipment. NEMA is a big deal. NEMA 1, 2, 3, 4 through 9, the standards. Specific applications of switch gears. And so there's a lot of NEMA enclosures, for example. NEMA 1, NEMA 3R, NEMA 1, 2, 3 to 9 starters. All these are listing and labeling for equipment that you can use. ANSI, American National Standard Institute, is another third-party verification tool. Consists of those concerned with the scope of provision. They have a lot of standards too. Canadians, we try to harmonize with them a lot. So this is your CSA, Canadian, slightly different than a secret book. But these are third labeling that you can use, and if you use any of these ones, your chances of winning at least a case if something wrong goes is much higher. Cool. Electrical Association, electrical inspector, those guys are specialized in the training of inspectors. So is this important, guys, to know what those guys are thinking? Yep, because guess what? Those are the inspector who's going to enforce the law, the code. So it's really nice to belong to. You guys, this is us, designer, very, very important. Later on, as a matter of fact, as in 2 weeks, you will be with Chad, your friend, will be doing Illumination Engineering Society of North America, IESNA. You guys are going to be using these standards for the lumens, lights, that's going to hit your head and give you how many foot candle you're going to have. This is, please highlight this one, very, very big deal. Now, Jamie, since you can't be an engineer, there's a couple of things you can be, a certified lighting designer. Certified lighting designer, they call it. They use IESNA lighting handbook. You guys remember the booklet that you were laughing at me when I gave you that? Now, it was a cheap book, really good introduction to lighting science. But if you want to go deep into it, here's where you're going to go, to the lighting handbook. Lighting handbooks, guys, tons and tons of information about how, from the science of the eye into the science of the light and reflection and so forth. So there's a lot of information. But I can't emphasize, if you guys highlight this one for me, because later on, we're going to be using IES. As a matter of fact, Jeff, IES file, IES is a file. Every fixture right above your head, you're going to be downloading an IES file for it. It's like DWG file. Remember the DWG file, right? Or the doc file for all these different files. The lighting, the standard in the industry for lighting is IES file. So if you want to have any fixture and do calculation in there, you're going to ask 2 questions. Number 1, get me the IES file in there so I can run it and give me a short. So IES, if you get the IES and the spec about this lighting, you got everything you need. Okay, so these are 4 lights. National Electrical Installation Standard. There's a lot of installation standard, guys, that those guys can do. Conduit bending, rigid. Have you done that, Darren, when you guys did that? We have here in our colleges standards for bending conduits, standards for installing MC cables, standards for workmanlike manner. Workmanlike manner, they define it in a big standard. What does workmanlike manner do mean in the NDC code book. So these tons of installation. And if all hell break loose, what do you have? You have your registered professional engineer. In the state of Minnesota, guys, if you, and a lot of other states, if you have a nice, beautiful switchgear came from China, and you want to install it, and it's not UL listed, what do you do? It's not UL listed, but you need it. Piece, not just switchgear, say a machine coming from Germany, you want to bring it here. Your option is to have UL list of it, but it doesn't have UL listed. Most of them do, but if it doesn't, then in the state of Minnesota, if you go to Department of Labor and Industry, they list many, a list of names of registered professional engineers in the state of Minnesota whom you can hire. I'm not one of them, whom you can hire to be basically to study this piece of equipment and sign off on it that it's equivalent to the UL listing. A friend of mine does that. So then they fly you all the way to China to go into the factory and see how they make it, and they give you all the specification about the equipment. You have to read them and understand them, analyze them, ask questions for their technicians, go witness their tests in their facility, and write a report. Your report will say, based on my judgment as a competent professional engineer, electrical engineer, I believe this equipment is equivalent to the UL listed equipment. Done. Then you can install it. Any comments, guys? And there's a list of names and for the state of Minnesota that can do the professional engineer. A couple of things about abandoned. What do you do for abandoned cables? If you have abandoned cables, this is kind of shifting. You're supposed to remove abandoned cables, high voltage, low voltage, and so forth. We do this one in the specification. A lot of engineers add this one if they're remodeling. Abandoned electrical equipment and cables shall be removed. Right in the specification if you're doing remodeling business. Because people, if this is not to be used, they just leave it there. I want you to remove it. Because why? Anybody knows why? If this is not used, why do you want to remove? You have to maintain a building, guys, for 50 years. Do you want the electrician to look here? They hire an electrician and say, oh, let's go fix that one or troubleshoot that one. It's not there. So it's confusing for the people who are going to maintain the equipment, right? Safety related to maintenance of the equipment. If you can make maintaining the equipment easy, safety will be improved, right? Okay. The last thing, guys, talks about, obviously, we're in 2011 here. The last thing is SI, system units and measurement. There's the soft conversion and the hard conversion. Soft conversion, approximate; hard conversion, the exact number. We talked about these one in a second here. So, for example, a couple of things, guys, comparing between a couple of systems here, the NEC customer unit and the NEC and the exact SI units. So, trade sizes. Everybody knows when we say 3/4 of an inch conduit, it's not really the interior diameter, it's slightly bigger. They always do the interior diameter is slightly bigger, and the metric designator is also related to the trade name. Everybody knows what a trade name is. We'll see a really nice example here. The metric is based on the 10. Everybody knows it's based on the 10 system. We talked about this one. The most important thing about the metric, the mega, kilo, these are very important, guys, and we've been using a kilovolt amp, megavolt amp, kilovolt, right? These are very, very important quantities to understand. Okay, here's my favorite. Look at this one. It's rate size, and we looked at this one before. We have an EMT here, EMT, and we have ENT, and we have flexible metallic conduit, and we have rigid metallic conduit and intermediate metallic conduit. All of them are 1/2 inch. And look at the actual interior diameter of each one of them. Which one of them is the largest, has the largest interior diameter? IMC, right? And all of them are called 1/2 inch. So that's why, guys, when you go and find, if you go to a 1/2 inch rigid, it will IMC, it will house more conductors than if it was EMP. Okay.
Is there a specific reason for that?
Different manufacturers.
I mean, my thought would be the corners would be take the 90 or whatever degree angle that it would
Yeah. I don't know. Why don't they standardize them? That's the question is. Well, some of them are actually like, for example, if you PVC, if you take PVC, that's completely different manufacturer than rigid. So they're done by different manufacturers. So in order for all of us guys to use this kind of some type of language, you standardize it, and the code has tables that list how many conductors can fit in each one of them. So you don't have, then you don't have to worry about the exact actual interior diameter. Yeah, because that's going to affect how many conductors you can fit in these. Yes, sir.
But couldn't, like, let's say you have two different people manufacturing, like FMC, couldn't the inside diameter be different per manufacturer?
I think there you're listing if it's, I believe it's FMC, for example, if it takes a label FMC, they have to follow certain criteria. I'm not sure if one of them is the interior diameter have to be the same. But otherwise, well, they have to, otherwise they can't use the tables. If I have half an inch FMC from manufacturer A and half an inch FMC from manufacturer B, you would hope I can grab the any sequence book and find how many conductors. You would think you'd have to. If I would say you have to, because otherwise you can't use the code. So, but FMC and rigid metal conduits are completely two different things. So, okay, so this is just FYI conversion from metric to meter into inches, guys. A couple of this is my favorite here. If you multiply a meter, basically roughly is 3 feet, right? A meter is 3 feet roughly. I'm sorry, yeah, roughly. So that's a couple of applications where you can calculate. I gave you guys a calculator, an electronic calculator. You can calculate all these stuff with them. Okay, so that's basically what I wanted to cover in this chapter. And if you allow me to just flash a couple of my stuff here, and I know I go over the most important things. The rest is guys FYI. Okay, so here's a blueprint and sections. Now these are directly from the book, guys. Concrete block, how to label them and all this stuff. This is FYI only. If the more you coordinate, look at the plan view section and elevation for each one of these, how they are shown for the architectural. Feel free to look at them at your own time. Elevation views from the outside for this building, the windows and so forth. This is all other disciplines. Why do we care about this? Because when you become a project manager, guys, drilling a hole in concrete wall is completely different than drilling a hole into a sheetrock wall, right? So it becomes a big deal when it comes to understanding the construction of the equipment. So I'll let you guys putz around with these. Mechanical. Look at the piping. If you are now, again, it gets overwhelming, guys, because I know you barely can keep up with the electrical stuff, let alone the mechanical and architectural. So here's all the symbols that they use for the plumbing, for example. So please look at these, FYI. The nice thing when you are working on a project, if you see something and you're not sure if it's electrical or not, what I've done, Zach, in the past, if I'm not sure, the mechanical engineers will be sitting right next to you, or you know what the mechanical engineers, right? Pick up the phone and ask them what's my interest in this piece of equipment? Is it electrical? Does it need an outlet? Does it need to be powered? If it's not, who cares? I mean, or if I want to put a conduit here, can I put a conduit here? Does it meet the code? So that's where you get interface between them, but there's a lot of information, guys. Sections, the same thing, ducts that you can take your equipment through. Arc, this is an arc flash, arc blast. Look at that one, that you can the big explosion that comes out of arc flash. My favorite is I always use this one. This is the temperature result of test, guys, that you can do the sound, the temperature that can hit you at different areas. So this is just to get you an idea that if you have an arc flash condition, which looks something like this, something like this, an arc flash condition, here's what you're going to have. You're going to have big ball of fire burning you. You're going to have extreme light that make you blind. Extreme noise, it's going to make you deaf. And if that's not enough, you're going to have a pressure, wave of pressure that push you off the ladder and tip you off so it can break your neck. So you can't have a worse scenario than that. So take it serious. Take it very, very serious, guys. I used not to take it serious until I read and saw a lot of incidents. You can lose your life. I know we're not electricians, but you are going to be around the electrician. Talked about this one. White book, guide information for electric equipment. Everything, guys, have to be listed. This is a white book that lists all the UL labels for equipment. Really cool. If somebody wanna, what the UL standard for switchgear, no problem. You can go to this book and it allows you. I have one really nice white book in my basement. All what you have to do is go to the NEC code book. It references all the NEC code book equipment articles to the UL. So, okay, fixture, lighting fixture. What's the UL listing for lighting fixture? Go to the article 410, and it refers you into reference these to article 410. If you know that fixture is on article 410, that's all what you need. Reference it. It makes it really easier. I know you guys are not at this level yet. Standard for labeling and distribution transformers, bunch of other stables. Okay, this is really nice how the NEC code book, guys, is labeled. You know the chapter 1 through, these are the chapters, then the articles inside them, then parts, then sections, then paragraph, listing, exception, and informative. So I can't emphasize, you have your chapter, inside the chapter, multiple articles, inside the articles, you have multiple parts, then multiple section, then paragraphs, and listing. And the most important thing is exception to and informative annexes in the back. This is a designation. We looked at that one. Conversion. Here's the actual dimension. We talked about 4-inch boxes, guys. The actual dimension is different than the exact dimension that you can do. Okay, that's all what I have for you. Any comments, any questions? Any comments, any questions? Please read this chapter, guys. There's a lot of information. All what you need to do, get the best out of it and move on. You will spend all your life trying to coordinate with other disciplines. So this is not... Okay, I'm going to give you guys 5 minutes, and then I'm going to walk you through this project that we have with a blueprint. So let's take 5 minutes.
Then we're doing our test, right?